We're asked to evaluate what inverse sine of negative square root of 2 over 2, negative square root of 2 over 2 is. And if you're not familiar with this notation, look, we're supposed to set it equal to something, right? We're supposed to figure out what this equals. So we'll say it equals y. And you can use sine on both sides to keep a balanced equation. Sine is the inverse function of inverse sine, so it leaves you with this. And that might be something you're more familiar with. We're supposed to find the angle of that makes a sine ratio of negative square root of 2 over 2. Okay, so this is what we started with, and this, I just rewrote it as an equivalent problem like this. Supposed to find out what y is. So to do that, let's see, there should be two, right? Because there's two places where sine is negative. If you draw an angle here, it's going to be positive because your opposite is in the positive direction. The hypotenuse is always positive. Okay. If you draw a sine over here, the opposite of the reference angle is positive. So sine is positive both here and here. We need a negative square root of 2 over 2. So that means we want to go down on the y-axis. That way our opposite is negative. So these are the two triangles where we can draw to make a sine ratio that's going to be negative. Okay. A quick mnemonic device students use is that all students take calculus. All are positive here. Just sine's positive here. Just tangent's positive here. And just cosine's positive here. Okay, but you don't have to do it that way. You could do it the way I just did it. So we're supposed to figure out what the angle is. And if you remember, the square root of 2 over 2 ratio happens when you have a hypotenuse of 1 and the two sides are 45 degrees. Okay? If your hypotenuse is 1, then the two other sides by the Pythagorean theorem and by opposite angles having corresponding side lengths, they both have to be square root of 2 over 2. Okay, so that's the angle we're working with down here, 45 degrees and 45 degrees. So our final answer is the angle from the initial side. How many degrees do you have to rotate to get to each of these side lengths? Okay. And so for this one, it's 180 plus 445. So 225 degrees is one of our answers. And then this one, we go all the way over here. So it's 315 for the other one. That's in degrees. And then if you want it in radians, the quick trick is to divide by 180 and stick a pi on there. That's now radians. You just have to reduce. 315 divide by 180, stick a pi on there. Now it's in radians, just reduce.